Fantastic. All right. Hi, everyone. Welcome to this special event between Casey Cardinia Libraries and Casey Tech School. My name's Tim. I'm from Bunjil Place Library, and today we're going to be looking at something really exciting for Science Week. We're going to be talking about designing sustainable houses and ways that you can make your house a little bit more energy friendly. We're also going to be talking about a really cool design program called Energy 3D and how you can have a play around it at home to think about maybe installing solar panels, or how you can, if you're building a home, how you can plan and design it with sustainability in mind. Joining us today from Casey Tech School is Kim Musgrove, and Kim is a bit of an expert when it comes to sustainability from her own personal experience. She's the owner and designer of Earth Shack, which is an 8.4-star eco home in West Gippsland. Woohoo! Goodness me. She is a passionate sustainability advocate, and she loves to do designs of backyards and landscapes with a sustainability focus. And before she did Earth Shack, she was a home sustainability assessor as well. So we're talking someone who's a bit of an expert in this category. Thanks for joining us, Kim.
You're welcome. Great to be here.
Oh, well, we're pretty excited. Every year when we celebrate Science Week, we try and give the community a little bit of learning knowledge on a scientific topic. And this year we're talking about sustainability, which is more prevalent than ever before. And people are always thinking about, either designing homes, building homes, planning homes, or if you're a younger person, maybe thinking about getting into architecture and design and planning. And what we talk about today might be of help to you as well. So do you want to tell us a little bit about your experience, Kim?
Certainly. I do get a little bit excited about this topic. So if I see Tim flapping his arms around, he might be getting me to move on to the next part. So as you can see, this is us under construction. So Tim's done that little bit of an intro there, so I won't say too much about that. But I think what's interesting to note is that this is it is something that you can go into regardless of sort of what your background was. So I didn't go through with an architecture background to end up in sustainable housing. I came with an education background and then have basically gone and sought all of the information that I needed and the courses that I needed to transition across to build my knowledge in this area. I was passionate about it. I loved doing it and it was fun. So I found it, quite easy, because I think it was just something I was so keen to get involved in. This little cutie slide is here just to remind people that this is a real house. So it's not your classic display home. So real people living in a real house. And so you'll even notice in some of the photos that it looks like a real house. It won't be a picture perfect display home, because that's not what it is. It's a real home. So what I'll start with here is this is just showing the importance of understanding how a building fits within the environment. So where Earth Shack is, we're actually in a rural setting. So I understand that a lot of people are going to be building in a more developed area, possibly an estate, but that we still look at similar things. So even in Casey Cardinia areas, we need to be really mindful of in the summer situations, we have a lot of estates that border with grasslands, farmlands, parklands. So as much as we don't want to have to think about an element of fire, it is something that we would always consider no matter where we're building in Casey Cardinia area. So in my situation, I have two sectors. If we analyse what's happening around the property, both the north and the southwest, which would be prone to fire. So as I plan and develop the house and the immediate area around the house, I need to keep that in mind and how I can reduce the impact if we do have a fire situation. The other thing that's always really relevant, regardless of where the house is going, is where that really bad weather comes from. So in my situation, my really bad weather is going to come from the west. And you'll see that the house is designed with that in mind, because if we ignore that, we actually can have a house that's really exposed to the extremes of weather, wind and rain, and that will impact the internal temperatures of a house. So we always consider what's happening in a broader landscape when we're trying to design a house to work as efficiently as possible. And that's the little summary you can see down the side there. So fire, including for mine, actual fire access, and also the effect of wind. Now, that might not just be devastating wind. It may be harnessing really nice, cooling southerly breezes, which will be quite different to a devastating westerly. So we can manipulate that to our advantage to help with our efficient house design. So that devastating westerly that I was talking about, this is looking in that direction. So you can actually see the house has been dug in, so that we've got the height of this retaining wall here, and then there's also a barn, and that's all protecting the house from what could be really strong damaging winds, and also winds that would impact the internal temperatures. So that's how we've managed that. I won't go right into our fire setting because that could be an hour just on that, but we've planned around that as well.
I think we could do a whole talk on just the fire safety at your property as well, Kim.
Oh, absolutely. I love that topic too. So we'll do that one another time. So this is what the house looks like from the outside. This 8.4 down here, what that means is that it has an 8.4 star energy rating. So when a home is built from scratch these days, it needs to meet a minimum of 6 stars for its energy rating. Previously, that was 5 stars. And when we designed and built this house, it was still a minimum of 5 stars. And we were trying to get the star rating as high as we could, because basically if we go for 10 stars, we know that's the best you can get. That is a house that should need no heating and cooling through the whole year.
What?
So the closer
is that even possible? Is that possible?
Yeah.
Oh, wow,
there is the first 10-star houses just starting to be built. So 8.4 is amazing, but obviously 10, well, that's where we're sort of aiming for. So we wanted to really exceed the absolute minimum and go well beyond that. In this, this is the south side of the house, and that will become important as we start to look at what we need to do on both the north and south. If you haven't got a compass, I would highly recommend getting the compass app happening on your phone so you know which way north is. And yeah, they can be a bit temperamental. So sometimes an actual real compass can be better. In terms of where this is relevant in that, so from sort of Casey Cardinia, well, from the tech school, from the Casey Tech School in Berwick, it's a 40-minute drive to where we are. And the reason that is relevant is because obviously the climate is the same. So what works for my house in my area is going to be the same for Casey and Cardinia as well. This photo was taken during construction and during a 5-day workshop where other people wanted to learn how to build their own sustainable homes, coming from all sorts of different backgrounds. And so we opened up our build for people to come on site to get some hands-on experience so that they could then go away and build their own homes, which several people in that photo have now done that. So that's really lovely to see. So in the context of our build, we're off-grid. Off-grid means lots of different things to different people. In our context, what it means is that we need to have our own energy system. So we're not connected to the mains electricity with the power poles at all. That connection is available for us, but we're not connected to it. We're also off-grid, needing our own water supply completely for the house and also for the rest of the farm. And we also need to manage our own waste. So like a lot, this one's more common in properties that are rural. It's not connected to main sewerage. So any waste that's coming from the house, from showers, kitchen, toilets, all those sorts of things need to be managed on the property. So, which is quite common. However, what we've done is probably not as common. And I'll get to that one a little bit later. So in terms of energy, this is basically what we need to have, like solar panels. So many houses now have got solar panels, and they we know how solar panels work. So I won't spend hours on the ins and outs of solar panels. But with this slide, the point was just to show that because we are off grid, once the sun goes down, so that we can still keep things running and I can still keep doing Zooms like what we're doing now, that energy needs to be stored somewhere. So we have this huge battery bank. This is full of batteries, this big box here, and the energy is stored in those batteries so that we can keep using things into the night, so that Xboxes can keep running, washing machines, all of those things that lots of families like. We do have a backup generator, so that if in the middle of winter, if we get cloudy day after day after day after day, if we need to, we could use that generator, and that does use petrol. So we're not what we could say 100% renewable. We're very close to it. That probably gets turned on twice a year at the moment. So we, in what we'd call in permaculture, which is another interest of mine, which is still sustainable design, we would call that backing up our major functions. So something that's really important, you need a backup plan. And so that is what our backup energy plan is.
I definitely think that's definitely true. We had a lot of colleagues that have been hit by the power outages in the last couple of months as well. So, you know, knowing that you've got a backup is a great idea. When you put the batteries in, did you have a certain level of energy in mind that you were working towards, say, your output for the house? Did you have a bit of a number that you were working towards in kilowatt hours to know how much solar panelage and battery you would need to install before you did it?
Yeah, so it was all calculated quite precisely so that we didn't spend a whole heap of money on solar panels that we didn't need. It was calculated based on how many hours a day do we think we would use a television, how many loads of washing are we going to do a week, and that calculation came out with that we needed a 1.75 kilowatt system, which sounds incredibly small. Most systems that get put onto a standard home now would easily be 5 kilowatts. That's really common. The reason that ours is so small in that regard is because the heating and cooling requirements of the home are so small. And so because of that, we can put on a much smaller system. So because of the design of the house, we can have a much smaller solar system. The system is actually now 2.97 kilowatts, and that's sitting there ready in case we go on to develop some sort of eco cabins. It has the capacity now to take the cabins as well.
Great forward thinking.
Yeah, it's ready. It's cabin ready. So I normally don't like to do slides with a lot of writing, so anyone who has seen me do it before, but this one's super important. So I'll just pause for a moment for someone who wants to read that word for word. So the importance here is that heating and cooling being 40% of the energy bill, if we can get that right, we have pretty much halved the energy bill. So that's what we'll sort of focus on with the design that we look at now, is what can we do to affect the heating and cooling? And getting that right at the start is really important. So this brings us to passive solar design. Some people find this topic really quite confusing, and I'm not quite sure why. Sometimes it's because we get confusion between the hemispheres. And so we read a lot of information coming out of America or perhaps the United Kingdom, and it will actually say the opposite to what we need. And I think that creates an enormous amount of confusion. So I'm going to make it really simple here for us so that we all know which way to go. Because if we get this right, you're on the right track. And this is something that when I was being a home sustainability assessor, it's one of the hardest things to fix if it wasn't done right in the first place. Because if we have a house that's basically facing the wrong way, we need to pick it up and spin it. And obviously that's just not going to work. So it's a really difficult thing to retrofit and try to fix after. So it has to be done right in the design stage. There is a term about to come out in a tiny little clip that's going to show, and it refers to shading. So before we get confused, shading for this one is actually talking about the part of the house, the roof that sticks out further than the wall. So in my one here, this veranda coming out is my shading. There are other types of shading, but for the purpose of the bit that I'm about to show you, we're talking about how the roof comes out like that.
You need to combine passive heating with passive shading to be really effective all year round. So how does passive shading actually work? This clever design feature works because the sun is at a different height in the sky in summer and winter. If your living room is facing the right direction and your shading is the right size and type, then in winter, when the sun is lower in the sky, it can sneak under your shading and warm up the room. While in summer, when the sun is higher in the sky, your shading can stop the sun from entering your room. So how much shading is needed for this to work? On the northern side, remember this should be where your living rooms are, the right shading will block the summer sun and still allow the winter sun to reach the windows and warm up your home.
Okay, so we only needed that little snippety bit, and I'll show you what that looks like on the house here. So this is the north side of the house, and so that word north becomes really important. So when Tim takes you into Energy 3D later, just keep thinking north, north, north for pretty much everything. So here's a winter photo, and you can see the sun's popped out from behind the clouds, and we get a huge amount of sun hitting these windows on the north side of the house. And you'll see that most of those windows are really quite large. And it's slightly difficult to see in this photo, but on the outer edge of my veranda there, I've actually got clear perspex. So that's why it sort of looks a slightly different color. It's a bit more obvious over here. So what that's doing is that's allowing in maximum winter sunlight into the living room so that it comes in several meters into those living areas. Then in the springtime, you can see that we've got a little bit of a shadow here because obviously, you know, spring is in between summer and winter. And what will happen as it gets to the summertime is this shadow will actually be the whole way down, shading the entire wall on that north side all the way down and starting to shade the concrete there as well. And that's what we're after. We want all of the sun to be able to come in the winter because that's free light, but it's also free heat energy. And then in the summertime, we absolutely don't want that to come in. And that's where the sizing of this veranda or an eave, if it's a lot smaller, is absolutely crucial for that to be able to work properly.
So you did that when you were planning your window sizes as well to match the size of that eave over the top as well?
Yeah, so the draftsman is able to calculate exactly what the widths need to be. So we would see at that point if we had an issue with it, we could make adjustments before we went any further. And so we could see on the calculations that if we didn't do this clear section, it was going to impact our winter light coming in. So yeah, it can all be checked at the drafting stage to know that it's right. And you're exactly right, Tim, depending on what size these windows are, whether they go down to the ground, whether they go all the way up to the ceiling, that impacts the sizing of this veranda. So this is underneath that bit I was talking about. So it's not incredibly pretty, to be honest. So like that could be done probably with glass, and glass would look really quite schmick. So we've done, I suppose you say, the budget version. How can we get the light in without spending $15,000 on glass was probably what decision was being made there. So this is the wall of the house on the left-hand side. So it's closed in here to create the summer shading that we need. And then it goes to clear. So the winter sun will come through that, and it will still come under here as well, under the right next to those veranda posts. So this is what I was talking about at that drafting stage, how we can see the differences before we go ahead and build it, so that we know we've got it right. So the W is for winter. So the outside of the house, we can see significant sunlight is hitting that north side. Inside, we're going to be expecting this with large amounts of area lighting up. with the sun coming through. Springtime, we've only got the tiniest little slither still coming through, versus summertime, you can see we've got full shade happening on the house now, which is what you want when it's 30, 40 degrees outside, and inside fully shaded, so that we have got nice cool temperatures happening on the inside as well.
It must be when you say it like this, it makes me laugh, because I just think of there must be a lot of people who don't have that feature, and they probably are just regrettably turning the air conditioner up every time it gets to that time. But I suppose having that mitigated sunlight in summer must really, keep the place nice and cool.
Makes a significant difference. Significant, to the point where obviously when the sun goes down in the summertime, it's going down in the west, sort of sun rises in the east, sets in the west. And to stop that low summer sun coming in through windows to the west, I just didn't put any windows to the west. So that's a really good way to block afternoon sun in the summertime. Not always going to be practical for every house that's being built in every situation. You might need to do some sort of a blind or a shutter on the outside that comes down to create the shade that you need, where I just didn't put the windows there because it does create an issue with west facing glass. So again, sun. Now north facing again. So when we keep looking at what needs to face north, nearly everything. So we've gone for solar hot water. So we've got 3 panels there, and we're a family of 4. So what this means is that in the winter time, we've got heaps of hot water still because we've got that 3rd panel. In the summertime, we have too much hot water. So what we actually do is we jump on the roof and we cover one of those up so that one of them is shaded.
I'm so relieved that's what you were going to say. I thought you were going to say we jump on the roof and we have like a big jacuzzi bath and we use up the rest of our water. And I was thinking, gee, that's a bit of a waste. No, that's smart thinking. So you can cover up. That's probably something that not everybody knows about solar panels. So you can actually cover some of them up to reduce the amount of solar energy that you're accumulating.
Yeah, so this is something else that gets a little bit tricky. So these ones here are solar panels, and they're completely different in how they work to solar electricity panels. So my solar electricity panels are on the barn, and that was that nice big long row of classic solar panels that we saw, and they create the solar electricity. Where these ones are different because they literally have water inside them. So the water moves through the panel and gets stored in here, and it just keeps going around and around and around, and it's getting hotter and hotter and hotter as it keeps going around. So in summer, it boils. You can hear the water in here boiling, which doesn't cause any damage because it's designed for that, but we obviously don't need that hotter water. So we cover one up. And so we find that that works really well because it gives us heaps of hot water in the winter, but also heaps in the summertime. So, and we can boost it. We do have actually a wood-fired oven in the kitchen, which we can use as a boost if we need to. But it's very rare, even in the winter time, that we would need to do that because we've got those 3 panels there. Often in housing estates, I love driving around to see what's happening with new builds. Often there's 1 panel. That drives me a bit crazy because if you look at the sizing of what's actually required for a family, you're going to need 2. And beyond that, if you want to be a bit crazy like me and have way too much hot water, then you would start to look at 3. But often 1 is put on because it meets these minimum requirements that builders will be chasing. But in terms of meeting the hot water needs of a family, it won't cut it. I think if a person lived alone, yeah, but often houses are being built for more than 1 person. So we should be looking at 2 straight away.
Well, that's interesting too. I'm sure there's a lot of people out there that are looking at houses now and would be thinking about, oh, it's got that solar hot water, but how many panels give you a bit of an idea about how many people can probably have a shower.
Yeah, and if there is one, it's going to then rely on the boosting system a lot more. So whether it's a gas boost or an electric boost.
And it's going to cost you more as well.
Yeah, and then we start to pay and, yeah, it starts to be not so good for the environment, but also not so good for the bank account as well. So yeah, if at the building stage, it's not that much more expensive to put that extra panel on, and it can be added after as well. So I definitely would go for 2, would be the general information. Obviously every house is slightly different, but in a very general way.
And everyone's shower is different too.
Yes, that's right. Well,
there you go.
That's exactly right. So this just reinforces that north facing aspect that we have. So these large windows should be facing north. So when you go into 3D, that's where you want your large windows to be. If you have solar hot water, again to the north, because the winter sun is going to be only on that north side. So if we were to go and pop that somewhere else in the winter time, it's pretty much going to get close to, depending on where you've placed it, very minimal or potentially no sun on it. And the third one, which really needs to have the orientation right, is also the solar panels. Now, being off grid, our time of the year where we need to be more careful with our power and maximize it to that and get as much as we possibly can is going to be the winter time. So this is facing to the north and it's on the perfect angle for the winter sun. If we were on a grid connected system, it would be perfectly reasonable to have some of these panels facing to the east if we use a lot of electricity in the mornings. So if you get up and you turn on the washing machine and the tally's going and everything's a real morning house and lots is happening, we would want to be using some of that energy then as soon as we create it. That's how you get sort of the best bang for your buck with grid connected solar. And same goes for the afternoon. If it's a household where in the afternoon, say anything after 3 o'clock, there's lots of computers being used, the television's on, and that's when we're using the washing machine and the dryer and everything, then it would be completely reasonable to have some of these panels facing to the west, because that's when you're demanding electricity. So you're best to be using your own at that point in time. So grid connected, we can go north, east, west. Off grid, which is what mine is, we go north, generally speaking.
And also think about, and that's something that you just touched on then that I think maybe not everybody thinks about, is what time of the day you're utilizing your energy as well. Because I mean, if you're on grid and you're talking about things like off peak and on peak times to use your electricity, this is the same thing really. Essentially, you're thinking about if you're using it in the morning or in the afternoon and where you're going to get optimum amount of energy and whether you want to produce the most. You talked a little bit about that angle, and that's something that the program I was going to talk about very soon is good too, because it allows you to articulate the angle of the solar panels. And there is an optimum angle, isn't there? Like having a flat roof and having flat panels on that roof may look slick or efficient in a design form, but that doesn't always necessarily equate to the most efficient energy absorption, does it?
Yeah, so it's, again, it probably depends mostly whether you're going to be connected to the grid or not. So when you're connected to the grid, your main goal is to produce as much electricity as you can over the whole year.
Okay.
And so once you start to do some calculations in Energy 3D, you'll see that the angle of those panels becomes less important, because obviously the sun, where the sun is sitting in the sky, changes. So where mine is really good for that low winter sun, in the summertime, a flatter setup would actually generate more. But I don't need to be generating more in the summer. I only need to be generating more in the winter. So that's why mine are angled for that winter situation. But in a grid connected system, you could have them flattened off more, because you're trying to get that balance of high amounts of electricity all year round. Some people will go to the extra expense of having them on trackers that follow the sun, like literally through the day.
Really?
So they'll move them. So
That's awesome.
I mean, that's optimal because it's following it perfectly, regardless of the time of the day and the season. So
that must be is that at the top of the range, most expensive?
It gets pretty
okay.
So does that make sense, Tim?
Yeah, it really does. That's something to think about if you're planning and doing some design work about what side you're putting your panels on and the purpose of them. What are you trying to achieve with your solar energy production as well? Are you using it all time? Are you on the grid? Are you off the grid? Yeah, lots of things to consider.
And if you buy a house that obviously already has them on, then you need to work within what's there. So what you would do is you would go, okay, what have I got? Okay, I've got 6 facing to the north and 4 facing to the west. So if I use electricity in the middle of the day and later in the day, then I'm using my own electricity that I have generated. And that's the best thing that you can do if you have a grid connected solar system. So you would set timers so that your washing machine comes on during that time of the day. You set all these timers so that you deliberately use as much of your electricity based on the way that your panels are facing on a pre-existing build.
Terrific.
So this one, it's a bit of a funny photo, but what I'm trying to show with this one, if we take a closer look at the windows, this double glazed window, often people will go, oh yeah, double glazing, yeah, it's got 2 bits of glass, which it absolutely does. The most important part of the double glazing is actually the air gap in between those 2 pieces of glass. So what happens is as the heat tries to transfer through the window, it has a really difficult time getting across that air gap. So if we just have 2 pieces of glass side by side, it won't work anywhere near as well as the 2 pieces of glass with that air gap there. So in Europe, they're often pulling out their double glazing because they want an even better energy performance, and they will then put in triple glazed windows. So that then has 3 pieces of glass and 2 air gaps.
Wow.
So,
thick.
And their climate's quite extreme. So like when we're looking at sub-zero temperatures, it can, keep people alive. And when we saw those devastating storms in America sort of 12 months ago when the electricity grid failed and people were trying desperately to maintain the temperature in their house for survival. So we're fortunate here that our climate isn't as extreme as that. But unfortunately, that bit more comfortable climate has also meant that a lot of our housing built over the last 50 years has also been a bit, she'll be right kind of thing, which has had some devastating consequences.
I suppose if you're ever getting too warm or too cold, you can always crack the window or open the window. But if you've only got 1 pane of glass between you and the outside, then there's nothing you can really do to keep it warmer. So
yeah, that's right. And we do still get extremes. Like it's not, Melbourne will often get 40 degrees and we will get, where I am, it gets down below 0 easily in the winter time. So we do get some extremes. So this is just the sizing here that's really important. So this is the north side, really, really big. And then when you're in Energy 3D, we make the windows to the south a lot smaller. That's a whole nother story in itself. But basically, we can get a reward from having large windows to the north that receive free heat in the winter time. We cannot get that reward from south-facing glass. And the window will always be the weak point in a wall. So we minimize how big that weak point is going to be. So even these windows, once the sun goes down, they will be the weak point in the wall. So really, I should have beautiful big curtains on the inside there to add another layer of insulation. Have I done it? No, because the house works really well. I haven't done it because the house is amazing. But yeah, we minimize our glass to areas where we're not going to get a positive gain from them.
I'm very excited to show you the house I've done in Energy 3D, and for you to critique all of the mistakes that I've made in designing it. This will be wonderful. I'm going to have so much fun. You will. Yeah.
So if we look at the internal floor plan, and this is something that you could spend a really long time on itself, so I won't stay here for a long time, but I will point out that north is off the top of the screen. So we throw all of the kitchen, living, this is the study to the north, because they're the areas where we want lots of natural light, we're reading, we're cooking, and we want that light coming in, and we sit around in those areas. So we want them to be warm in the winter time. So that's to the north. Other areas like bedrooms shouldn't need as much light. So they've been thrown to the south, and they've got the smaller windows again, because we don't need as much light. If you're trying to have a multi-purpose room that is both a study and a bedroom, well, then you start to have to weigh up what you're going to prioritize. And all of the wet areas we've kept in one area here, and that's obviously the kitchen there. So all the plumbing is consolidated to one space, so that we're not just wasting money running pipes all around the place unnecessarily. These green arrows show at the very start, we talked about harnessing cooling breezes. So for us, they're going to come along a valley from the south. So I can open these windows along here. Even this one can still often grab it, because the slope sort of comes up that way. And
clever. It
will easily push fresh air through there and then out that side. And then these open up, and the windows open up significantly. They don't just sort of wind out a little, they open right up, so that we can get maximum airflow within just a few minutes. And then we can close it back up again if we want to, or leave them open. This one here, that's the floor plan with a few little pictures, so it's a bit easier to see. And the yellow is just signifying that free winter heat coming into those areas along the north there. It looks like it's cooking the roast chicken, but that was just to show that that's the kitchen.
I was going to ask, do you use this? We use the sun to cook as well.
Yeah, that's the solar chicken cooker.
That's quite remarkable, the way that you've created those pathways through to utilize essentially like free air conditioning. That's very, very clever, and not something that everyone has the luxury of doing. But it certainly goes to show you that there are ways when you're designing a place to utilize the natural energy sources around you, rather than having to reach for the fan or reach for the heater.
Yeah, definitely. And often on a house plan like this, there would be a hallway right through the middle here. And that little dotted line looks like one, but it's actually not. That's just the center point of the ceiling. So by not having a hallway there, we can get that really easy airflow through here. And we actually have an activity at the Casey Tech School where we look at passive airflow and air movement. And it's really interesting to see how that will work easily. But as soon as we put a hallway there and it creates a U shape, we have significant trouble getting natural ventilation through once you're asking it to do a U shape. So that's where getting rid of that hallway, that solves the issue most of the time. So in here, this was going to be a little bit of a guess as to, we'll see if Tim can get it. Tim, can you see something there that I may be using as insulation for my walls?
Oh.
And it's not my husband.
I was going to say, did you put him in? Well, goodness me. I'm going to guess it's the hay bales, is it?
Well, yes, very close. So they are bales. So they're bales of straw. So
okay, sure.
That's why I have my background like this today. So when they do look like hay, it's hard, you can't see the difference. The difference being that straw is we go along and we harvest the wheat or the grain off the top of it, and the wheat or straw is what is left behind, where hay is cut grass. So the reason we use the straw bales is because straw has a really high insulation value. So a bit like when we looked at the double glazing, and that little air gap was really important to help stop the heat transfer through the double glazed window. Those little tiny air pockets that are inside that straw bale are going to do the same thing. So heat has a really difficult time transferring across through that straw bale. So they're a terrific insulator. They're also a great building block, sort of just stretch a pattern. So beginner builders like ourselves, we could build ourselves really easily with that. So my park ranger husband turned into the builder to build the house, and he could do that because it's an easy building medium.
Wow.
Is
there any concerns around, because you're using straw, do you have to, fumigate it or anything like that?
No. So all we do once the render is on, because often we get two questions. We get, aren't the mice going to eat your walls? Once there's render on, they can't get at it. They actually can't get in there because it's as hard as concrete, and it's 5 centimeters thick. The render, so that protects it, and also it's protected from fire and any effects of rain by the render as well.
So it's pretty much nullified all of the problems I was thinking of.
Yeah, so we would expect this house to still be here in 100 years. So we've designed and built the house expecting that it will still be perfectly livable in 100 years' time.
Fantastic. And really good use of natural resources as well. I mean, you obviously use straw for a few different things in agriculture, but that's a really smart use of something. Were you able to, did you harvest it yourself, or is that something that you were able to get up relatively cheap? Or?
Yeah, we had to buy them.
Yeah.
So I can't remember exactly how much the bales cost for the whole build, but not a significant cost compared to your plumbing and electrical and all of those sorts of things. But they, we just sort of bought them from Northern Victoria at the time. And the other thing is that straw is often a waste product in the agricultural sector. And so once the wheat is harvested, sometimes those fields, and often those fields, will just be set on fire. So of course, then what we're doing is we're burning this great carbon, and it's going up into the atmosphere when we could bale it up and build houses out of it. And we've captured that carbon, for the life of the building. So, and then at the end of the life, after 100 years, you could argue that you could break the render off and mulch your garden in 100 years' time, or your great-grandkids can. But yeah, so it's got quite a few things going for it in terms of sustainability other than its insulation value.
Unreal. What other things did you consider with your house to help maintain the temperatures and try and utilize the natural energies around you, I guess, to try and keep the house cool in summer and warm in winter?
We were drawn to straw quite early, and so we were pretty hard to budge from that. And because we could use it ourselves when we were wanting to build a lot of the house ourselves, so that became really important to us. But the other thing that I sort of would consider as well would be a wall that is twice the thickness of a standard wall. So rather than just following standard building regulations and putting up your standard wall, I double the width of that so that you can put double your amount of normal insulation. That would probably be a backup plan if I couldn't get straw.
Smart thinking.
So this is the kitty lynx just having a bit of fun, putting on a little bit of render, getting a bit hands-on. And this just helps us to see different sorts of insulation. So there is quite a number of ways you can do insulation, and this just shows the two. So our external walls are the straw bale, and our internal walls, so say from one bedroom to the next, we're using quite standard insulation bats there that you see really commonly in the big packets, and you pop it open and stuff them into the wall. Having said that, you do want to put them in properly. So if anyone's going to put in their insulation, you don't want any gaps. Make sure you put it in really, really well. So what has that left us with? So we recorded the temperature in the house for 5 years. So the hottest that the house got in summertime during a 40+ heat wave was this 22.5 degrees, which is a really lovely temperature in the summertime. So it was sort of 5 days of 40-degree temperature outside, and the house still didn't go over 22.5. So we do have ceiling fans that we can turn on, but we sort of wasted our money on those because if I turn them on, then the kids run off and get a blanket. So I probably could have not worried about the ceiling fans.
Well, I mean, they look shiny. They look nice. There you go.
You live and you learn.
It's a little bit like how electric cars make a motor noise, because people like the idea of a car having a revving engine, but they don't actually make any noise other than that. So there you go. You've got them for the sake of having them there.
Yeah, we thought we probably would need it, even just for that feeling of air movement. We thought it might feel quite stuffy, but it hasn't ended up that way. So then in winter time, the lowest that we recorded in that 5 years was 15.5 degrees. And that would be, we went away for a few days, so we weren't using our oven. And so in this house, the oven is the only thing that generates any heat. There's no other heating sources at all. And so the house held a 15.5 degree temperature with absolutely nothing happening in the home, and without the oven being used. So my oven is this black one here, and may not look like your most typical oven, and that is actually a wood-fired oven. So when we talked about backing up our major functions earlier, being on a farm, you can see out the window there, we have significant trees that are always dropping limbs and everything onto fences. So we can use that resource, and if we need to warm the home, we can do that, and we can keep the house at a comfortable temperature.
Making use of the resources you've got. Great thinking.
Yeah. So this is sort of a summary of where we've got to so far. So if there's 3 important things to remember when you go into Energy 3D, we would remember that north facing for windows, roof, and the living areas. So those 3 things, we want all of those to be facing to the north. The shading, so making sure that roof sticks out further than the wall, which is going to create that shadow for the summertime sun, and that wintertime sun is going to be lower in the sky, and it's going to be able to sneak under that little bit that sticks out and come in to heat the house up. So if we did a house without that, you'll find that it's going to need quite a bit of air conditioning to try and fix up that issue that we've created by not having that sort of part, the eave sticking out there. And then insulation. The more you can shove in the walls of that house, the better. And that's why I deliberately found this great photo. Often when we look into the roof of a house, the insulation barely makes it to the width of that bit of timber work that's used to form the ceiling. This is what we want to see. That's probably a little bit similar to mine. I think that might be even slightly thicker than what I've got in my roof. But you want it really, really thick for the Victorian climate. Our winters are cold, and we want to, when you turn on a little bit of heating in the house, we want that heat to stay inside. And by having this insulation layer across the roof, which is like a nice woolly blanket, it's going to help to keep it inside. And it helps in the opposite situation. When it's stinking hot outside, it stops that heat trying to come through the roof or through our walls. It works for both summer and winter. We've got a couple of snazzy things, Tim. Do you feel like getting a little bit snazzy?
Oh, I reckon we could go through them real quick and have a look at some of these things, because when you were showing me before, I think there's some stuff here that people may not even think about when they're designing their house, or even improvements that they could add on to help reduce their power bill and the impact on the environment. So yeah, go ahead.
Okay, I'll do 3 quick ones, and to keep it don't take up too much of your time. So this one we've got at the front door. So this is our cutoff switch. This is super easy for an electrician to wire in during the building phase, not very expensive at all. So as we go out the front door, this one that's got a silver cover on it, so we know which one it is, we can flick that, and that will shut down the whole house. So it will turn off any lights that have been left on. It will turn off the TV if that was left on, and it turns off all standby power. So we've all heard of our mobile phones using a little bit of electricity, and the DVD player, everything uses, all those things use standby power. This will turn all of that off. So basically we're not wasting energy when there's not even somebody in the house. And that is cheap to wire in, really great thing that should, I think, just go into every single build now. Really, really easy one.
And just to be clear, that's not your fridge or your freezer, any of those sort of essential devices you need to keep going.
Yep. So the electrician makes sure that the fridge and the freezer aren't wired into that. And so they keep going, because the last thing we want to do is get food poisoning. That won't be much fun.
No way. Do they flag which power sockets are connected to it? Do you have like a color tag or anything on them to indicate, or is it just a given that those ones that are where your main appliances are plugged into will just, yeah?
Yeah, so if I tried to get a bit sneaky and put my fridge into a different location to where it is now, I would then have to get the Sparky back to make an adjustment, because I said on the plan, I want this one and this one to not be affected by the cutoff switch. So it's wired to those points.
Ah, cool.
Yeah. So this one is a cooling cupboard. Now, this one is not going to be very common, but it's super cool, and you'll see why. Will be the cooler side of the house, and here we have basically a big concrete pit, so you can see down into that pit. So the cool air on the southern side of the house is going to sink down into this pit, and then there's two pipes down there you might be able to see, where that cool air is going to go inside those pipes and inside to the cool cupboard. So we'll go inside now and see what this looks like on the inside of the house, so that we can understand how a passive cooling cupboard works. Okay, here we are inside now. So this is the cool cupboard on the inside of the house, and as you can see, it's part of the normal kitchen. So the cool cupboard, when we open it up, is basically like a refrigerator. So we keep in here fruit and vegetables that likes to be kept at a cool temperature. It's not as cold as an electric fridge, which will be down at around 2 to 3 degrees. This is going to be more anything from about 4 degrees to about 12 degrees. So we do get some variation on this depending on the outside temperature. So as well as storing obviously a whole heap of fresh fruit and vegetables in here, we can do that without using huge amounts of electricity that a massive fridge would use. So the two parts to the cool cupboard on the inside that are important, the pipes coming down the bottom here. So we can't actually see the pipes that are coming in from the outside because we've got this mesh over it, but it allows that airflow to come from the pipes up through the mesh, and we deliberately have slatted shelves so the air can continue to travel through the shelves, through the baskets that are also slatted, and all the way up through, and at the top we have a vent which can be open as much as we want it to be for increased airflow, or we can close it slightly to decrease the airflow. So it's not actually a fan, there's no electricity required for that, it's purely a vent that goes through, and it looks like a chimney on top of the house. So as that little flue or chimney gets warmer on the outside of the house, just from a little bit of light and sun on there, the warm air rises, and that's what draws more air in through the system. So we have continuous airflow so that we can't have problems with mold or stagnant air or anything like that. Easy.
That's amazing. Very innovative. So it's essentially like a climate cooled cupboard that you can use to, because there's nothing worse than having a warm apple. Yeah.
Who wants a warm apple?
But you don't also necessarily want a freezing cold one. So now you've got your best of both worlds.
Yeah, and I suppose we have a lot of fruit comes off at certain times of the year off the property as well. So rather than having a large commercial cooling area, we can put, several baskets of whatever is coming in at that stage, and to store it, at a reasonably cool temperature. But you wouldn't put your milk and stuff in there. It's not cool enough. Sometimes it is, but not through the summertime.
I think you're probably taking a bit of a gamble with your dairy, but I still think that that's really great, and probably practical too if you're a person that does their shopping at a market or goes market shopping and you find yourself with like extra vegetables or things that you could buy in bulk and keep them in there. Smart thinking.
Yeah, and it's there is modified versions of this that it can be piped in as a cooling option for the house as well. So where we can find the cooling to the cupboard, you could adapt that and use it as a passive natural cooling system into the room. That would be another way to use it.
great thinking. Cool. Multi-purpose.
Multi-purpose. So we'll go really fast here. So this one is the water. So I suppose the important thing to note is that particularly when you're off grid or as soon as you need to pump water, the water system and the energy systems are connected. We have to think of them together. And a lot of rural properties I assessed, they had trouble bringing their energy bills down because the way the pumping had been set up was really difficult to modify. So what we do when it's sunny and we've got more electricity than what we can possibly use, we would turn on our pump then to basically waste a bit of our electricity, I suppose you could say. We pump up to this header tank here, which you can see is higher than the house. So then now whenever we turn on the taps, turn on the shower, it's just gravity bringing that down to the house. So we're choosing to make the most of our electricity when we have too much, and then using zero electricity in terms of water through the rest of the time. This one is our waste treatment that I was talking about earlier. And basically it's super fun because it is a gigantic worm farm. So when we look inside, this is what we can see. If you look really closely, you'll see some worms. There's a nice little one there. You can sort of see them crawling around on everything. So that all the waste from the house is going into there. Kitchen, showers, toilets, everything, as well as you can see we've thrown other things in there as well to help the worms. So some bananas, and that's paper. All of those things are getting thrown in there and they love it. So all the waste from the house filters through that worm farm and then it goes off to the pasture. So where a traditional septic system on a farm holds on to all of the water and they get really quite smelly, there's no other way around it. There's a lot of greenhouse gases being produced in a more traditional septic system. So the idea of this one is
hey, hon, can you shut the door?
Water. It's not storing the water, and so therefore it's a system that has a lot of oxygen and it produces less greenhouse gases. So that was our environmentally friendly option for dealing with the waste from the house.
And that's a great, it must be really fun for the kids too to go and throw all of the scraps in there as well.
Yeah,
it'd be a bit gross, but yeah.
And fantastic. It's not smelly. It's not smelly like a septic system would be.
Woohoo! Even
there
better.
You go.
So leaving us with our top 3 efficient design tips. We mentioned them before, but the insulation, that shading from the summer sun, and that north facing windows and roof, really smart thinking. We're going to apply some of those in Energy 3D in just a moment. Kim, that's just wonderful. If people wanted to find out more of your experience and knowledge, do you have a place where people can get in touch or find out more? Have you got a recommended place to check out that to find out more if people are interested?
Yeah, yep. So when we're not in COVID times and we're all locked down, we do open up the house for people to come through so that they can see it and understand it. It is that bit easier when you're in it. At the moment we can't because of the lockdowns, but the property is called Earth Shack. So anyone who wants to keep track of where we're up to and see when we open again for in-person tours can go to earthshack.com.au.
That's terrific. Well, while we're on the idea of designing a sustainable place, let's take a look at doing some digital design work. So if you're interested in maybe building a place, or you're in the process of thinking about how you could improve the design of a house that you've already got, or if you're interested in maybe even just the idea of engineering and design, and you want to find out a little bit more about solar energy production and how you can better improve your designs and use a sustainable approach, you might want to check out this program. So it's available free to download. Energy 3D is the name of it. And I'll give us the website at the end of it too. So if you want to head there and download it, you can check that out, which is really great. But just to give you a bit of an idea about it, it's a 3D CAD program. So you can use it to build a 3D model of a structure. You can also add things into it, such as trees. And you can see there that I've also added on some panels as well, and I've got some windows in there, and I think I've got my door around here. I sort of just did a bit of a basic design because I wanted to get some feedback from you, Kim, about it, because I can instantly start to see a few problems with my design. But for those that are getting started with this program to begin with, there's a couple of things. I might just open up a new one just to show you what it looks like when you first open it up. There I am, hanging out in my cool yellow shirt. And when you want to build, the build commands are just here at the top of the screen. So you've got the option to add a wall. You can add an interior or exterior wall. So you can just click on your grid and you can start to build wall by wall, just clicking and dragging your mouse to build walls like that. The other thing you can do, if you find it a little bit difficult modeling in 3D, is this program has a view mode, which allows you to look 2D top down like a bird's eye view. So you can see the shadow of my person there. You can see I've got 2 walls there already. And as I add more walls in, you can see that there's a grid feature that is kicking in to help me with my measurements as well. You'll also notice just when I turn it back from 2D mode to take that one back off, you'll see in the bottom right-hand corner that I've got my little compass, which you were talking about before, Kim, which is very essential when you're designing your house to think about what face, what direction we want our house to face, and when we're putting our windows into our property as well, to make sure that we're putting them on the correct side of the house, whether we want it north facing, or if we're putting our panels in as well, making sure that we put them on the right side of the building. So once we've got our walls in place, we can add a roof as well. You can roll your mouse, you can zoom in and out just like that. You can add a roof to the top of your structure once you've got your 4 walls in place. And you've got a few different options. So if you click on the little down arrow, you can choose from a variety of different options. You've got pyramid roof, hip roof, shed roof, which is the one that you saw on my building before. You just make a choice. You can always increase or decrease the height of your roof as well. So if you are feeling like maybe you want that the roof to be a bit flatter, you can lower it by clicking the dot at the top and just raising or lowering that roof however you feel. And then, of course, you can start adding in your features, such as your windows here. So thinking about what you were saying before, Kim, the side that I want my big, wide windows on was my north. Is that correct?
That's it.
That's it. So using my compass here, I'm going to pivot around, and this should be my north side here. So I'm going to put a window in. I'm going to make a nice, big, beautiful, big one, just like that. And you'll be interested to know also you can move your window as well. So what Kim was saying before about making sure that you've got a wide enough eave on your roof, and thinking about the position of your windows, the closer that you get it to the roof, obviously the more shade it's going to get, depending on what time of the day and what time in the year. So having a big window is all well and good, if it's on the north side, but you've also got to factor in a few things around the size of your roof, and also if anything's going to be obscuring that window too. And that's where we can have a little bit of fun. Underneath the windows, you've got things such as doors. You've also got plants as well. So if you wanted to put some trees there as well to create some natural shade, you could. And if you right click on the tree, you actually have some options to change the type of tree that it is. So make sure if you click on your tree, you got it selected. And then if you right click on it, you can actually change the type of tree that it is. So you might want to have a big pine tree, if you want it deciduous, or if you want it evergreen. Is evergreen and deciduous the same thing?
No, so
the opposite, right?
So, and it remind me we'll click on something else while we're in that view there, Tim. So a deciduous tree will drop all of its leaves in the wintertime. So in my photos, you might have seen big oak trees that had perhaps dropped their leaves. So they're the ones that we call deciduous. Yeah. And then where an evergreen, it's sort of like it's green every day. That's how I sort of remember it. So
never
it's
loses
evergreen,
its leaves.
so it holds on to its leaves. So we would want, if it's coming in close to the house, we would use the deciduous trees, which are going to be your things like your oaks. You'd stay away from anything that's see, a lot of those are deciduous. Don't do a pine tree. You don't want a pine tree, you don't want a gum tree, keep them well away.
Yep.
But yeah, anything deciduous, or if it had the option, a deciduous vine can work really well, like perhaps grapes or kiwi fruit.
Smart thinking. Well, there you go. So you can.
There's something that's driving me slightly crazy, Tim. I need you to click on it for me.
Yeah, go ahead.
Can we make it Melbourne? So up the top right, so our shadows are right.
So this is it. When you're opening the program, because it's an American design software, it's going to be thinking that you're in the Northern Hemisphere, and you don't really want that. So if you're planning on building a house in Australia, and particularly in Melbourne, what you can do is if you click away from your tree or whatever part of your building that you're building at the moment, and you go up here, you can change the date. So you can set the date to today, for example. So we're on the 17th today, so we're all good. But you can see that we're in Boston. We don't want to be in Boston. So if we scroll down the list and we look for the M's, we can find Melbourne on the list, which is really great. And what that'll do is that'll start to enter the data in to reflect. Now it looks a bit better, doesn't it?
Because I'm happy.
Our sun is shining in from on the north side of the house now, and we're starting to get our shade and our shadows on the opposite side.
An Aussie house now, Tim. It has to be an Aussie house.
Yes. Now, if you really wanted to get technical, you can adjust. You can start to look at the house at different times of the day. So at the moment we're at noon, but if we wanted to change that, we can type in a different time. So say we wanted to do 4 o'clock in the afternoon, we could go a little bit further. We could do 4 p.m. and hopefully it does it. No, it doesn't love us. So what we might have to do is we might have to enter in our, oh, there we go. Oh, hello. No, we've gone to 4 a.m. But you can click that up and down and it'll jump ahead hour by hour, and you can start to see the sun moving around. Now that's really fun, and because it allows you to play around with the positioning of your things. You can also see here that my tree has lost all its leaves because we've set it in winter, or we've set it, we're almost in spring now, but it knows because of that it's in spring. So if we jump a few months into the past, if we go back down to February, you can see that our tree is in full swing there. So that's going to be really helpful for you when you're planning a year-round property, thinking about those things when you're designing your house. Now, not only can you just do it hour by hour, the cool thing about this program is that you can actually create a heliosphere, which if I just zoom out a bit, looks a bit crazy. It looks like something out of a science fiction movie. This actually shows you the arc of the sun on a daily basis according to the date that you are looking at. So you can adjust it to see where the sun is going to be. But if you start to tweak it too much like this, it's going to lose the correct alignment there. So it's always good to just leave it out to give yourself a bit of perspective about where that sun is going to be. And if you're thinking, solar panels, maybe using this information will allow you to make an informed choice about where you want to put those panels. You can run that sun through a day cycle to get a bit of an idea about where your positioning of your windows and your solar panels is by running that sun around. So you can just hit the play button to see your sun move around your property. Now, as well as a roof, we can always put a door in as well. Look, don't have too many choices. It's a pretty boring looking house, unfortunately, this one, but we'll put in a door anyway. And we'll go back to the one that I had before in just a moment. Just got to remember where my doors are. Aha, there they are. We'll just pop a door in this side here. So we've got some way to get in. This last option here is to do with your solar panels. You've also got that option there for the solar water heater as well that you were talking about before. You can put in a rack or you can put in a single solar panel. And from my experience, I'm no expert at this, but from my knowledge of using it, you do need to find a surface that is big enough to hold the solar panel. If it's not big enough, it will tell you that the panel does not fit on that part of the building. And you may need to make your wall a little bit bigger or your roof a little bit wider to try and fit it in. However, once the panel is placed, you can make it smaller or larger depending on what you need. So at the moment, I've put it on the west side of the building. Is that a good choice for a solar panel position?
So if we were on a grid connected house that's going to use a lot of afternoon electricity, so anything after sort of 2 o'clock in the afternoon, then some west facing panels is okay. To put the whole system to the west would mean that you don't want to be using any or a little bit of electricity through the whole rest of the day. But yeah, some to the west would be very reasonable on a standard grid connected house for most situations.
If we were going off grid though, would we want to position them to the north?
Yeah, off grid we would throw them to the north.
Okay,
yeah.
Great. Well, let's put in a rack on this side as well. You'll see there that it rejects it. Doesn't really like it if it doesn't quite fit on. But once you've made that connection, then you can start to play around with moving it a little bit smaller, depending on however you want it fit. Now, on the right-hand side, when you select a panel, you get a little bit of information about it. So it talks a bit about the angle. It shows you the size, and it starts to talk a little bit about the capacity of them as well. So that's really helpful if you want to get into the maths of it, to be thinking about how many panels you want. If you right-click on it, what you can also do is you can do a daily yield analysis, and you can also do an annual yield analysis. If you do a daily yield analysis, you get a little bit more information that I found quite useful. Just remember that a lot of the prices in this and the money that's talked about is in American dollars. So you may need to think about it from an Australian conversion. So you might have to convert the money, but it sort of shows you up here the cost of the approximate cost of putting in some of these. Is that pretty accurate for it?
You'd get a lot more solar panels in Australia for $3,000. Yeah.
Wow, that's pretty good.
You'd get quite a few more. Yeah.
So what we can do is we can work out the calculated daily output of those panels, which is quite helpful if you wanted to then extrapolate that data or use that data to then forecast the capacity or the amount of energy that you'd be able to produce from using for those panels. You can also do a yearly analysis, which takes a little bit longer, which gives us a little bit more data month to month about how much it would absorb or take in. And you notice that the data changes depending on the seasons as well, the position of the sun, and it factors all of that in for you, which is quite good because it means you don't have to necessarily do all of that heavy thinking yourself, which is great. So there's some really basic things that you could use in this program to get a bit of an idea about where you're positioning your solar panels and how much they're going to cost you, but also how much energy production they're going to produce. Just remembering how many different appliances or different fittings are going to be using that, like you were saying about the hot water system, making sure that you've got enough energy to cover all of your needs is really important. So as well as doing that, there was something else that I wanted to show, which was this button up the top here as well. And what that allows us to do is it creates a heat map of your property or your house when you build it. And you'll notice that the different colors, we can adjust it a little bit for contrast just to get a bit of an idea. But the hotter areas or the areas that take in the most sunlight are the brighter colored bits or the closer to red. So you can see here the roof, the sides of the house as well. The walls of the property don't take as much heat. They're on the lower part of the heat map. But using a heat map is a really good way of working out where to place your panels, because it's going to give you the areas of the property that are more susceptible to sunlight. Is that right, Kim? Am I right in thinking that that's the way to utilize this tool?
Yeah, I haven't played with that function, but logic says going by where it's throwing the yellow versus the red to there, it seems to be basically where it's created a shadow at various points throughout the day. It's got those cooler spots. So yeah, that would be my interpretation of it, but I would probably look at it a little bit closer just to double check.
Yeah, but this is a this is a really handy tool if you're thinking about your own property, if you wanted to design your own or build your own house in it, to get a bit of an idea about where you can put those panels. And if you're someone who's really handy and likes to build stuff physically, so if you wanted to create a model of it, this software is really handy. It's got a feature that looks a little bit like a printer up the top right, and it will actually demonstrate to you, you can actually print out your design, and you can actually construct it out of paper or create a model of it if you needed to demonstrate or create a hands-on model to show other people your design choices as well. So there's a lot of flexibility involved in this. Let's go back to my previous design.
I think that would help you work out where to put your veggie garden too, Tim, because you'll be able to see where the sunny spots are, or where it might get too hot as well. It can help get your veggie garden in the right spot.
Well, genius. That's exactly the other thing that it's very helpful for as well. And where not to put your basil plant, which is continuously dying on me. So
yeah, or the worm farm. Don't kill the worms.
Well, yeah, that's exactly right. You don't want to get it too hot. They don't like it when it gets too hot. No way. Otherwise, you get a lot of dead worms on your hands. So let's take a look at my first try. So first things first. I've got my I've definitely got my biggest window on the north side. However, my tree might be a little bit too big. We might be getting too much shade. What can you see there that perhaps I could be doing a little bit better? Let's rotate it around.
So you've sort of got your tree to the north to provide a bit of sort of a shade and a shadow, but then probably I would have flicked your roof pitch the other way so that your solar panels were then towards the north as well.
So maybe yeah, definitely.
So you still hold that pitch if you like that funky pitch, but just tip it the other way.
So that it goes up the other direction rather than on the, I see what you mean.
Yeah, you've got sort of lots of south-facing panels at the moment, and they're going to struggle for large parts of the year, where if you flip them to the north, you'll get a lot more out of them. If you ran that simulation with the roof the way it was and then ran it again once you flipped your roof, it might not let you just flip your roof without.
I think I'm going to have to take my roof off and
put
swap
it back
on
again.
Oh, it looks like it's taken a bit of a beating.
Oh, look, you've damaged your solar panels, Tim.
I've killed my solar panels, haven't I? I'm going to have to get rid of my solar panels. And I might need to put my roof back on. Yeah, definitely a great idea. Yeah. So instead of going this way, what we want it to do is actually face that way.
Yep.
So now, oops, I clicked the wrong button. And we go around. There we go. That's looking better.
So if we'd run that simulation and got the output from our solar panels, how it was, wrote that down, ran it again with the roof flipped, you'd see quite a significant difference on what the solar panels can produce.
Cool. As for windows, there's not a lot there's not as much on this side. There's a much larger one on this side. Am I right in thinking that that's the direction that I want my windows to be if I want to capture any of that sun?
Yeah, so that in the winter time, that tree's going to lose all of its leaves. And so that nice big window is going to get lots of winter light and heat coming in. So that's really good. And then we basically minimize the windows on all other aspects. Cool. Or if you go as crazy as me, we don't put any on the west. But some people still want something to the west. And yeah, even if you just played with the simulation and looked at what happens with no windows to the west and then pop a couple of windows on the west and then run it again, you'll see the energy difference in the heating and cooling of the house within this program by just changing just the windows, for example, and nothing else.
Fantastic. All right. Well, that's sort of a basic summary of it. If you're interested in playing around with it, it's a free program. You can download that one. And I believe it's available at, I've got my notes on, I think we can just download it from their website, which I think if you look up energy.concord.org, CONCORD.org, you can download it and give it a play around. I recommend doing it on either any computer with a mouse and keyboard. Will work better than trying to use it on a touch screen, to be honest. It's a lot easier. and well worth a crack. Kim, it's just been wonderful. Thank you for joining us for Science Week. I think I've definitely learned a whole lot more about sustainable house design, and I think hopefully everyone out there in Casey Cardinia does as well.
Thank you.
If you want to find out a little bit more about Kim's work, you can find her at, what's the website again, Kim?
At Earthshack, so earthshack.com.au.
And if you want to find out a little bit more about Casey Tech School and what they've got on offer, they've got heaps of activities and stuff that they've been working on. If you've got younger people at home as well, or if you find yourself looking for stuff to do after school, they've got a few different activities that run. Casey's Tech School's got heaps of really cool stuff. They've got 3D printers, they've got laser cutters, they've got a whole bunch of really awesome stuff that's on show there. And you can check out their website at caseytechschool.vic.edu.au to find out a little bit more. Thanks for joining and celebrating Science Week with us. We hope you had a really eye-opening time, and we hope that we've saved you a little bit on your power bills too.